Hello and welcome back to Mr. Powers Teaches Algebra. We just went over explicit formulas for geometric sequences, and now I'd like to just share something with you, and this will work for arithmetic sequences as well. Just a quick technology video on how can you use technology to check your work with these. wolframalpha.com is extremely good with sequences. And actually, I probably could have just plugged it in. So the sequence we did last was 2, 10, 50, 250, and so on. And Wolfram Alpha, stick a sequence in there, hit enter, and it will say, oh, you put in a sequence. Oh, here it is. Here's my explicit formula. A sub n equals 2 times 5 to the n minus 1. Bam. It'll give us more terms if we want. It will give us some other stuff. And what's even more fun, let's see here, is, let's see, I think if we hit more here, there it is, we can get a recurrence relation. And what's interesting relation is that will be the way we can represent this as a recursive formula. So in other words, we could rewrite this as a sub n plus 1 is equal to 5 times a sub n. But normally the way we've been doing it is we want to know what a sub n is in terms of the term that came before it. So if we subtract 1 from n here, subtract 1 from n over here, and that will be perfect. I'm sorry, I wrote this wrong. Let's fix this. This was 5 times a sub n. And so now if I change, n minus 1 here, take 1 away from n here, so do the same to the right, it'll be 5 times a sub n minus 1. Both of these are fine rules, but for our purposes, normally we're probably going to write this if we're trying to write a recursive definition for this, this sequence. That would be our recursive definition. And our a sub 1, of course, would have to be part of it. We'd have to say a sub 1 equals 2. That's always very important. You got to at least define one thing if we're doing it recursively. So there is an example. Let's go ahead and show you one more example with an arithmetic sequence. All right, so here's an arithmetic sequence that we played around with before. 5, 8, 11, 4. Actually, I should try to make that a little bigger. And obviously, our common difference there was 3. Our explicit formula is a sub n equals 2 plus 3n. We did not find a recursive formula for this one yet. We could totally do it. I mean, it's add 3 every time, right? So each term is the previous term plus 3. That's not too difficult. But let's go ahead and see if Wolfram Alpha can do it arithmetic. So I copied those numbers in, hit equals. Don't forget the dot, dot, dot. It's huge. And there it is. A sub n equals 3n plus 2. Here's our continuation. We can click more here. And we should be able to get the recurrence relation. It didn't give it to us, though. So, well, actually, it won't give you a recurrence relation for this. It's just too easy. So anyway, that's it for this one. Until next time, enjoy doing math.